Neither philosophers nor neuroscientists will be the first to solve how free will, consciousness, or mental causation work in the brain, because the first to solve these problems was the intentionless but inherently exploratory mechanism of evolution by natural selection. Our job as scientists and philosophers is to uncover how nature solved these problems. Similarly, scientists in the past had to work out how nature had already solved genetic informational causation. They knew such causation just had to be taking place because offspring resembled their parents. They just didn't know how it occurred. Facing the mind-body problem, or mind-body problems, we know that people are conscious. Why? Because we ourselves are conscious, and that certain mental operations, such as volitional attention, are carried out over consciously experienced and reportable information. We also know that a thought arrived at after such conscious, deliberative operations can be followed by actions that then implement our intention. We just don't know yet the details of how this all works at a neural level. One great task of this and coming generations is to solve the various aspects of the mind-body problem that have stumped so many past generations since at least the time of the ancient Greeks. Principal aspects will include cracking the neural code, deciphering the neural correlates and causes of consciousness, determining the physical and informational mechanisms underlying mental causation, and of course, understanding how volitional processing is realized by neural circuits. Neuroscience has, I feel, finally developed far enough that it can take the lead in uncovering how volition, consciousness, and mental causation actually work, and perhaps offer new insights to philosophers that may be useful to them in addressing these core issues. Since evolution has astonishingly but blindly solved these puzzles, let me say a brief word about the process of evolution and the origins of the idea of selection. People tend to attribute the core idea of evolution by natural selection to Darwin, and certainly he brought the idea into biology. But the seed of Darwin's radical idea was already clear in the revolutionary work The Wealth of Nations by Adam Smith, published in 1776, which, incidentally, was also the year that his close friend and fellow luminary of the Scottish Enlightenment, David Hume, died. Smith's work is, as far as I can tell, the first mention of an unprecedented idea, namely that there can be creativity without a creator, or the emergence of apparent design without a designer, because of a two- or multi-stage process that Smith termed the invisible hand. In Smith's domain, there's a credit boom, part of the economic cycle, that leads to the formation of numerous companies. When the credit bust part of the cycle comes around, there's a shakeout that leaves fewer survivors, which then seed the next generation of proliferating innovations, followed by the next stage of selection or weeding out. For example, during the internet boom, there were countless companies, but after the collapse of the internet bubble, only a few were left standing, like Amazon, Facebook, Google, and so forth. In the next cycle of businesses, people mimicked these winners rather than the countless startups that failed. So, bringing this back to Darwin, Darwin picked up on Smith's idea, emphasizing that there was a first stage in which microscopic randomness was amplified to a stage of macroscopic phenotypes that was then subject to the withering forces of selection, both natural and sexual, which then seeded the next generation. William James then picked up on the same idea, arguing for a two-stage notion of free will, where largely randomly generated ideas were then subject to a stage of volitional selection. Selectionism in the brain, particularly the kind of selectionism that underlies our imaginings, may operate more like sexual selection than natural selection. Remember, natural selection tends to weed out the weak who can't evade predators or otherwise survive in the world as it is. In contrast, sexual selection, unlike natural selection, tends to weed in those with some desirable trait. In most mammals and birds, and even in some invertebrates like cuttlefish and jumping spiders, there is a sexual division of labor, where the males compete and display their plumage, strength, or other ornaments associated with genetic health, and the females select who to mate with, based on certain criteria that they have. If those criteria concern, say, antler size, runaway sexual selection can result in the giant antlers of the Irish elk, which were 3.5 meters or 12 feet across. In peacocks, sexual selection resulted in male tails so massive that extended flight was no longer possible for them. In our lineage, runaway sexual selection might have led to our massive foreheads and associated executive control and working memory areas and capacities. That is, these massive foreheads of ours lying over our huge frontal lobes that afford our awesome capacities to plan and to imagine might be the equivalent of our runaway peacock's tail. Now, I don't know for sure that it was sexual selection that led to our outsized frontal lobes, but it's certainly a possibility. Another possibility is that culture began to co-evolve with our genes, and that it was those groups that could best maintain and propagate information socially in a culture that best survived, and that in order to maintain a culture, working memory, planning, imagining, and executive control areas are necessary. Under that scenario as well, we might have ended up with these massive foreheads. It might be hard to settle how we ended up with the large frontal lobes that we have because neural circuits don't leave fossils, thoughts don't leave fossils, nor do utterances. All we have to go on are bones, some tools and artifacts, and genetics. So, imagination may be the result of sexual selection, and by analogy, it may in part work like sexual selection through the top-down imposition of selection criteria. Here's an example. We may have some need. Say we need to build a bridge. In the first stage, we generate many possibilities. We could use the island in the middle of the river or not. We could build a bridge out of wood, stone, steel, or even gold. But in the second stage, we select from among these possibilities using some evaluating criteria. Now, these are not genetically pre-programmed criteria like those in the brain of a peahen looking for a massive tail in a peacock. Instead, these are criteria that we maintain in working memory, like minimizing cost, maximizing strength of the bridge, and so forth. We rule out possibilities under these criteria. A wooden bridge could burn down. A golden bridge, that would be too expensive. We settle on steel and using the island in the middle of the river for support because this will optimize strength and minimize cost. Now we repeat the process in a way analogous to the genetic algorithm of variability in each generation followed by selection. We generate many possible steel bridges in our mind, then select from among them. Eventually, we evolve in our imagination toward an optimal or at least adequate solution over the generations of our variable ideas and selection among them. Again, all taking place in the virtual reality of our imagination. We evolve towards an optimal solution first in our minds, and then we go build it. It might not be the only possible solution, but it will be one that optimizes across all the criteria we have set for the building of the bridge. So in this way, the operation of the human imagination may be analogous to sexual selection that operates over generations, not of animals, but generations of our half-baked ideas.